Today I'm speaking with Dr. Sarah Buckley about her ongoing research on oxytocin and birth. Sarah and I connected on Instagram recently when I posed the question, can we be sure that synthetic oxytocin does not pass the blood-brain barrier and impact mental health? The answer isn't completely black and white. So join us as we explore oxytocin, the incredible hormone for birth and breastfeeding. Now I bring you Dr. Sarah Buckley.
Hi, everybody. You are very welcome back to the next episode of the Tracy Donegan podcast. And today I am delighted to welcome Dr. Sarah Buckley. Sarah is the author of Gentle Birth, Gentle Mothering, and the brilliant 2015 report, Hormonal Physiology of Childbearing. So if you are a new birth professional out there, this is a paper you absolutely have to read. And reread, I think, several times. So just to give our listeners a little bit of context, back in March, I had posted on Instagram asking whether it's true to say that Pitocin never crosses the blood-brain barrier. And we're going to get to that in a minute, but we're just going to start with some information on what is oxytocin. And Sarah, you are very welcome. Thanks for joining me today.
Thanks so much, Tracy. It's a pleasure. Yeah. So a little bit of background. I'm actually doing my PhD on oxytocin and childbirth. So it's a topic I've delved into. And I also have the incredible privilege of working with one of the world experts in this area, who's a Swedish woman called Kirsten Uvnas Moberg. Who's an emeritus professor. So we've been publishing papers together. And what we've been writing about are called systematic reviews. So what you do in that methodology is you gather all the publications in one area and you pull them together, and you can make conclusions based on the data. In some circumstances, you can integrate all the data and do a meta-analysis. So we've done systematic reviews on oxytocin levels when it's been measured during labour and birth, which is not so easy. I'll get to that. But we've done a paper and it's published and it's also open access, and I recommend you find it. Go to my website, sarahbuckley.com, click all the science, and you'll find this one. So we've done a paper on oxytocin levels in women and newborns following synthetic oxytocin exposure. Okay, so we've actually done the numbers, if you like. So a lot of what I'm saying comes out of that paper. But before we start talking about that, I think we should talk about actual oxytocin, natural oxytocin, or there's a word we say endogenous, like made in the body, oxytocin. And it is a hormone of labor and birth. It was first discovered as oxyfast-tocin birth. So that was the first discovery of oxytocin, and it causes the uterus to contract, makes birth go faster, causes contractions during labor, after the birth. The synthetic version of oxytocin, just to say this up front, is exactly the same as the whole molecule of oxytocin their body produces. So, for example, in those studies, you can't differentiate between the oxytocin that's being produced and the synthetic oxytocin that's being administered. So we'll come back to that point as well. But our own natural oxytocin is made in the brain. It's made deep in the brain, called the hypothalamus, stored in the pituitary gland, and actually we store a big bank of it before labor and birth, or at least rats do, and we probably do as well. Like the pituitary swells up to about I think 30% extra size, so it's got all that extra oxytocin that can be used during labor and birth. And then in labor and birth, what happens is we start to release it, and we actually release it in pulses. And the pulses become more frequent, and the amount of oxytocin or the height of the pulse becomes higher. And it's quite extraordinary, actually, that we can measure it in the peripheral bloodstream, taking a sample from the veins when it's actually being released from the brain. So there's very big pulses. In fact, one study actually measured it in the jugular vein, which was a bit extreme, and they found these very high pulses, so extremely high pulses. So it's pulsatile release in labor and birth. But the really important thing about oxytocin, and this is really the more recent research, well, the last 30 to 40 years, is the effects in the brain. So it's made in the brain, in the hypothalamus, stored in the pituitary, released into the body, causes a fast birth, all those things we talked about. But it also, just one more thing to say about that, it actually is also the hormone of the letdown reflex. So when you're breastfeeding, your baby suckles on your nipple, there's a positive feedback, goes up to the brain releases oxytocin contracts the myoepithelial cells, and you get what's called a letdown. The milk becomes available to your baby to suckle. And also, it's a hormone of orgasm in males and females and all animals, actually, or all mammals. Epidurals. This is an archetypal mammalian hormone. So just going back to oxytocin in the brain, so all of those things depend on oxytocin release into the blood from the pituitary. But at the same time, or there's a qualifying statement there, but usually at the same time, particularly in reproductive events, it's also released within the brain. So in the brain, oxytocin has the kind of effects, the reason we call it the hormone of love, right? Because it makes us feel calm, connected. It actually switches on the parasympathetic nervous system. And I'll just go back a step and say that that's a branch of what we call the autonomic nervous system. You could think of it as like the automatic nervous system. So it's the nervous system that's controlling your heart rate, your blood pressure, your skin temperature, actually, your gut, a whole lot of things you're not thinking about. And that's in balance between the parasympathetic, the rest and digest, calm and connection, and the stress system, the sympathetic nervous system, which is not just fight or flight, but also when we're alert, when we sit up, when we're kind of paying attention, that's all our sympathetic nervous system gets switched on more. But when we are under the effect of oxytocin in the brain, it actually switches that balance. So parasympathetic becomes dominant, we get more calm, our blood pressure goes down, our heart rate goes down, and actually, we'll come back to this point as well, our skin temperature increases. And the skin temperature is a very subtle way of figuring out the balance in the sympathetic parasympathetic, because when we have more sympathetic predominance, we get that fight or flight reaction where we pull all our blood into our core for fight or flight, our muscles, our large muscle groups, our heart, our lungs, for fight or flight, and our skin temperature gets colder. And when we're in the parasympathetic and that's not happening, our skin temperature is warmer. And we kind of know that, don't we? We say someone's a warm person, or we say, I've got cold feet about that. So it's kind of things that we know already. So sympathetic, parasympathetic balance. So in all of these ways, and more ways I'll just describe, oxytocin is called a neuromodulator. So within the brain, it modulates a whole lot of effects. So there's the sympathetic, parasympathetic, autonomic nervous system. It also reduces the other major stress system, which is the hypothalamic pituitary adrenal axis. So that's the medium-term stress response and cortisol. So oxytocin reduces cortisol as well. And actually, we published another paper about breastfeeding, and it was a paper that measured oxytocin levels during breastfeeding. And there was a beautiful paper where they measured oxytocin levels and cortisol, and they were like mirror images of each other. As oxytocin went up with breastfeeding, cortisol went down. So very powerful effect, very powerful anti-stress effect. So reduces stress, reduces sympathetic, reduces HPA and cortisol, also reduces fear. And this is part of that whole group of effects, really. So it reduces activity in the amygdala, the fear center in the brain, which has a lot of oxytocin receptors. We'll come back to receptors in a minute. So when we're not, when we're not fearful, we're more sociable. So oxytocin is also a social, we say social affiliative hormone in all mammals. And it's actually, we could say, part of mammalian survival, because mammals, the animals, the creatures that we are that suckle our young, we have mammary glands, but we tend to cluster in tribes or groups or social packs, and that keeps us safe in the wild, right, where we've been humans as well for millions of years. So that social affiliative characteristic of oxytocin makes us seek others, makes us gives us pleasure from interacting with others. That is also like a survival mechanism, and oxytocin has those social affiliative effects. But perhaps one of the most important effects I haven't mentioned till now is actually that it powerfully stimulates the pleasure and reward centers in the brain. So that's why it's such a feel-good hormone, and it's been called the cuddle hormone. Like when we hug people, it's social affiliative, but also it feels pleasurable. When we have a massage, when we do group singing, a whole lot of things. And in labor and birth, in sex and orgasm, it powerfully activates those dopamine, pleasure, and reward centers. So in the context of reproductive events, it's like saying, good job, like make more babies, have more babies, breastfeed more often, right? We want that to happen. That's important for species survival as well as individual survival. So all of those things are happening in the brain that I've described when we do things that release oxytocin. As I said, hugging, having sex, breastfeeding, making a baby, and having a baby, right? So having a baby has all of these effects, and having a baby is an intense experience if you've had a baby. Like, there's no way around that. Like, there's stress, there's pain, there's all kinds of things happening, but oxytocin is there to kind of reassure us and give us that calm and connection, switch on those calming, soothing effects in our brain, and actually activating the parasympathetic nervous system, keeping us out of stress as far as possible. And, it's not just humans we're talking about all mammals. So imagine a cat or a dog, never given birth before. What the hell is happening to me? So, it's very important that an animal doesn't get frightened and run away, or get aversive, or, get scared in that, and get birth trauma. It's very important, all of those things. So it's there to help us. As I say, your hormones are your helpers in labor and birth. And oxytocin is not just a response to stress, and not just a stress reducer, but it also is part of the response to stress. So when we're stressed, we actually release more oxytocin as well to counteract that stress. So that's why that's why a hug is so helpful. And some of the drugs that we're using for stress and depression, those things at the moment, like SSRIs, they probably work by increasing our oxytocin as well as other effects. So that's kind of how oxytocin works. And I'm just going back to something I said before, which is the receptors. This is very important. So oxytocin is a hormone. A hormone is a substance produced in the body, in one part of the body, has effects in another part of the body. And it has effects by binding with receptors. So it's like a key and a lock. So oxytocin's the key, the receptor is the lock. And there's often, not all hormones, but with oxytocin, there's one key and one lock. Like oxytocin the key doesn't fit other locks. Some hormones do. And generally, other locks don't fit the oxytocin. Other keys don't fit the oxytocin receptor. So they're kind of monogamous, which is interesting. It's called the hormone of monogamy as well. Well, we can talk about that. But anyway, so oxytocin works by binding to receptors, and these receptors are actually on the outside of the cells. Receptors are in different places. So imagine during labor and birth, oxytocin is released from the pituitary gland into the bloodstream, goes to the uterus. It finds the receptors on the outside of the uterine muscle cell. It binds to those receptors like a key in a lock, turns the key, sends a chemical message into the cell saying contract. Yeah. And that's how oxytocin from the brain causes uterine contractions. There's a whole lot of biochemical pathways in the middle and steps, but that's essentially it.
Hey there, if you're enjoying this conversation and are passionate about evidence-based care in labour, the best way to support our work is to subscribe and share this episode with other amazing women in your life. Your support is so important to us and helps us reach more mothers with empowering content. So go ahead, hit that subscribe button and spread the love.
And what we found in actually the first systematic review was on oxytocin levels during physiological labor and birth. And you can you can guess from everything I've said that oxytocin levels go up as measured in labor and birth. But as I mentioned, it's kind of tricky. First of all, there's pulses. So if you measure them right now, you might get the peak of the pulse or the trough of the pulse. So some of the studies we looked at actually averaged them out. They actually took blood over a few minutes and averaged them out. So there's that aspect. There's the aspect that it's very hard to pin down a woman in labour, as it should be. So thank you to all the women who participated in those experiments, especially the pushing stage. Like some of the studies actually are sampled in the pushing stage or straight after the birth. But the other thing is that oxytocin is actually broken down very quickly in the bloodstream by enzymes called oxytocinases. And of interest, oxytocinase is made by the placenta, and it makes even more in labor and birth. So it's critical when you're sampling the blood for oxytocin in pregnant women that you add a particular enzyme inhibitor to stop the breakdown. We actually found some studies that didn't do that and found no oxytocin at all. So the enzyme inhibitor is important as well. So all those things make it kind of tricky to measure in labor and birth, but it has been measured, and as we guessed, starts off low, becomes more and more as labor progresses, about 3 to 4 times higher at the pushing stage. And then after birth, this is very interesting, after birth, levels can go even higher. And when you've been through physiological labor and birth, there's some change that happens that we don't understand that makes the mother's body sensitive to touch. Yeah, makes it's particularly her chest. So this is kind of, we could say, our evolutionary blueprint. The baby's born, comes onto the mother's body, onto her chest. We get that magic of skin to skin straight after birth, and the mother's body actually pulses heat to the baby during that skin to skin episode. And that actually only happens if she's been through physiological labor and birth. So there's something that happens in physiological labor and birth, whether it's peaks of oxytocin in the blood or probably, we are guessing, in the brain, that switch on, that change the mother's body to have this, we call vasodilation, opening up of blood vessels on the chest wall. And if you look at pictures of women in those last stages of labor, I've got pictures of myself with the reddest cheeks, right? And it's this oxytocin flush. We can actually get it in sexual activity as well, where our chest gets red, it goes up our neck, even to our cheeks. And that's the flush that is designed to actually have our newborn babies survive. Yeah, because we pulse this heat to our babies. And just of interest, one of the papers I'm writing at the moment with my colleagues is about oxytocin levels during cesareans. And what we found in one of the studies is that oxytocin levels actually don't go up in new mothers in skin to skin contact with their baby if they've had a pre-labor cesarean. So something's missing there. We'd call that a hormonal gap, and something's missing. We don't know. It's the oxytocin peaks, obviously, whether it's in the body and the brain, that have switched on this mechanism to pulse heat to the baby and basically keep the baby alive, right? The baby's come out of this warm, wet environment. Like a baby would die of hypothermia if there was no heat source. And obviously we haven't had blankets and bunny rugs and the heaters and all those things for millions of years, or other mammals don't. It's all kept warm by body heat. So just going back to that time after birth, I was mentioning oxytocin levels. So one of the studies actually measured, and again, thank you to the women, oxytocin levels every 15 minutes during skin-to-skin contact after birth. And they found in some women, in one woman in particular, her oxytocin levels went up 10 times. From the moment of birth, remember that's 3 to 4 times higher than the start of labor. During skin-to-skin contact, it went up 10 times. And that was in response to her baby's activities on her body. So the baby on her naked, skin to skin on her, releasing oxytocin through the baby's initial breast massage, and then the baby's suckling. All of those things causes these big peaks of oxytocin in the mother. So oxytocin after birth, remember, it contracts the uterus, so that's very important after birth, seals up all those blood vessels that are kind of raw after the placenta's peeled off, stops postpartum hemorrhage. It saves the mother's life, saves the baby's life. It's very critical in that hour after birth as well. And that's when we get the highest levels. And sometimes I say, the birth, when the mother births her baby, she graduates as a mother. And after that, the hour after birth is postgraduate education. That's when all of these skin to skin, those peaks of oxytocin in the brain as well as in the body. Obviously, we can't measure it in the brain in human women, but it's switching on all of those maternal circuits, because that's part of the circuits of mothering that ensures survival for all mammals, that the mother will be rewarded and motivated to take care of her newborn babies, because it's hard work, right? If you had a baby, it's really hard work to take care of them. So Mother Nature builds in these mechanisms, which is actually stimulation of the reward and pleasure centers in all mammals. So the looking after the baby, for example, a study in rats was more pleasurable than cocaine. The mothers preferred their babies to cocaine. Yeah, it has to be that pleasurable. Otherwise, who do it, right? We just walk off and leave our babies. So the processes of labor and birth and these peaks of oxytocin in the brain switch on all of those things we're talking about and the reward and pleasure centers. And then after birth, the mother gets the stimulation of her baby, the sight, the sound, the taste. Most mammalian mothers lick their babies. And those sensory experiences get, we say, hardwired in the brain. They get fired and wired together with the pleasure centers. So from the get-go, the baby is a source of reward and pleasure for the mother. Yeah. And by the way, when I say mother and woman, I mean any female giving birth. Yeah. So it also applies to anyone who's got a uterus and all of those things. So yeah, that's kind of what I call Mother Nature's superb design and how our endogenous oxytocin systems work. And then every time that we breastfeed our baby, we get another release of oxytocin with the letdown reflex, and we get continually topped up with this hormone, this system, really, this caretaking system that's going to make sure that we take care of our babies, make sure that it's going to be as rewarding and pleasurable as possible. And not just that, but any time that we have our baby skin to skin after birth, for example, one randomized controlled trial randomized mothers and babies to skin after birth for, I think it was 4 hours a day the first week, then 2 hours a day for the first month. And those mothers and babies, those mothers had lower depression scores, and they actually followed those dyads up to 9 years, and they had a better relationship at 9 years from that kind of small change, we could say, in the early postpartum period in the first month. So skin to skin, even carrying your babies, releases oxytocin, and it's all, it's Mother Nature's medicine to help us to enjoy taking care of our babies, to make it as easy as possible. It's not easy, of course, but to make it as pleasurable as possible. So, we'll come back to that because, when we say hormonal gaps, when oxytocin doesn't have the opportunities to do all those things for us because of interventions primarily, then we can ameliorate that to a large extent through skin to skin contact after birth, through breastfeeding, especially exclusive breastfeeding, through skin to skin contact, through carrying our babies. I call it Mother Nature's backup system. So we do have those things at the ready. But just to say one more thing, which is, I hope it's obvious from what I've said, that time after birth or the time around birth, biologically it's called an early sensitive period. So things that happen at that time can have these long-term effects. They can change, we could say, the trajectory of the baby's well-being, the mother's well-being, the mother's and baby's interaction, which is why these hormones of labor and birth, that skin to skin contact after birth, the carrying, all of those things, the breastfeeding, especially the hours around birth. There was another randomized control trial, and this was done in Russia. You couldn't do this these days. Again, thanks to the mothers and babies, where standard practice was to separate the babies, swaddle them, place them in the nursery. So the intervention was skin to skin contact for the first 2 hours after birth. So the mothers were randomized to skin contact, and then the baby skin to skin contact versus swaddling versus taken to the nursery. And there was also difference. There was also babies that were swaddled and separated, but then later on given back to the mother for rooming in. So you could kind of see, is it the contact between mother and baby? Was there something particular about that early period of skin to skin for the first 2 hours? And what they found was that the mothers who'd had that skin to skin contact in the first 2 hours of their babies, they followed them up at 1 year and they videotaped their interactions with their baby. And again, like the other longer term study, they found that the mothers and babies interacted in a more smooth way. The infants 12 months old had more emotional regulation. So all of those things from like the first 2 hours. So that's really why we call it an early sensitive period. And just to follow up, the babies who were not skin to skin, who were swaddled and separated but then roomed in with the mother, didn't catch up. Yeah, so contact later didn't compensate for missing out on that contact early on. So a really, really important study for these times. And I think one of the very heartening things that's happened, and I'm sure you can reflect on this too, Tracy, in your times, is that we are more aware of that importance of skin to skin contact after birth, and it's become standard practice. So I'm kind of glad that study was done, but I'm glad that we're not doing that anymore, that skin to skin is standard practice. So that's endogenous oxytocin.
That's a lot. That's
That's a
amazing, Sarah.
lot.
Thank you so much. And like it's yeah, you can feel the passion about oxytocin in everything that you share. So I have a couple of questions for you. And as you're so familiar with the research, I remember reading a paper just talking about the receptors that people who have, and I'm not sure if it was done on men or women, people who have early, I guess, childhood trauma seem to have lower levels of oxytocin receptors in the body. Have you, because I'm just thinking about, with induction being such an issue at the moment across the world, and failed induction being a huge issue, and I'm wondering if if these oxytocin receptors aren't there, then I guess, yeah, because all of this kind of, wiring and receptors have to be in place, before that spontaneous labor kind of kicks off. So I'm wondering if is it possible there's women out there who, because of, childhood trauma, have lower levels of oxytocin, that maybe they're the moms who, labor, they're still pregnant at 42 weeks, or if they have an induction, that the induction just doesn't seem to go anywhere. Have you come across that?
Okay, well, I kind of agree with what the outcome of what you're saying, but I would say that the mechanism is different. So, what I believe is that all of these things are hardwired through millions of years of evolution. So, I don't really think our uterine oxytocin receptors, or even our brain oxytocin receptors in the mothering circuit, are that vulnerable. And what actually happens in labor is that, or in the lead up in pregnancy, is that we get increasing levels of estrogen, and estrogen is the hormone that actually upregulates oxytocin. So that's the hormone that activates the whole system. It makes our oxytocin levels higher, but it also increases oxytocin receptors in the uterus. So the whole system is becoming more active. And I don't believe that uterine oxytocin receptors are going to be impacted by childhood trauma. I haven't seen any studies on that, but I think that the evolutionary reproduction is so hardwired. I don't think it's going to be changed by that personally. But I do think that, and if we again go back to an evolutionary perspective, it's critical that the laboring female is in the safest place possible to give birth. And then, so what happens in labor, and there's a whole chapter on this in my hormonal physiology report, what happens in labor is the laboring female, I'm talking about all mammals here, is constantly assessing the safety of the situation that we're in. Is this a safe place to give birth? She has to feel like it's a safe place, even to start labor, right? Even to continue labor. So many women have probably had that experience of labor starts at home, everything's all good, and then you go to hospital and it all suddenly stops because you have this, we say limbic, like primitive brain assessment of the system that it's not safe. There's not familiar people here. It's not a familiar place. It smells strange. There's things happening. All of our senses are telling us this is not a safe place. No animal would go to a place that would give birth with strangers. No animal will go to somewhere that's strange to them to give birth. Like that is not a safe environment in the evolutionary sense. We might have this intellectual idea that it's safer to give birth in hospital, whatever, but our body has a different idea, right? Our body feels
Yeah.
safer at home. And that's why, home birth has so much lower rates of intervention, because we have this feeling of safety, and as I said, the hormones, oxytocin, but other hormones of making a baby are very similar to having a baby. And one of the things I say to people is this a safe situation where you could make a baby? Yeah. If it's not, then it's going to be hard to have a baby. How can you make your body feel safer? How can you enhance the safety of your sensory system? So I say things to people like, and I'm sure this as a doula, protect your hearing, like wear headphones, listen to something soothing, protect your eyes, so you don't see these strange things, wear an eye mask, protect your sense of smell. Smell is related to the oxytocin system and other mammals very closely. So smell good things, smell familiar things, reassure your system that you're actually safe and familiar, because familiar is safe, right, in an evolutionary sense. So I think the feeling of safety is what would inhibit labor, what would slow labor, maybe what even makes women not even start labor when they've got a history of trauma, a history of not being safe. Yeah. So I think,
Yeah.
as I said, I agree with what you observed, but I think the mechanism is not hardwired in that same way.
Yeah, really. Yeah, when on reflection, it really wouldn't make sense, for the human race to continue to populate it. We have to have a system that's pretty sturdy. And then there's this other aspect then of oxytocin. We know about oxytocin being, the love hormone, and isn't there an aspect though that I've read somewhere about it being a tribal hormone as well?
Yeah, so everybody thought oxytocin is the best thing since sliced bread. We should all have it. We should put it in the water, right? We should give it to everyone. It's going to cause, everyone to be happy and connected. But you're right, it is, we could call it a tribal hormone. So even though it increases connectedness between you and me, like we're in part of the same thing, we're in the tribe, we feel good with each other. Those people out there, oh, I don't know about them. So when we give oxytocin, it actually increases like suspicion and to outside outside people and aggression even to outside people. And if you think about, again, evolution, I mean, that's important for survival, right? We don't know who they are. We don't know what they're going to do with our babies, right? We want to be a bit suspicious of them. And for example, one study actually gave and I'll talk about this, synthetic oxytocin. So a whole lot of, because of everything that I've said, you can imagine that there's a lot of conditions where a bit more love, a bit more relaxation, a bit more sociality would be beneficial. So oxytocin's been trialed in all kinds of conditions, sexual conditions, social conditions, autism, even things like, osteoporosis, even vaginal dryness. Like there's a whole lot of areas where oxytocin seems to benefit, right? And the way that it's given is it's generally given intranasally. So you snort it basically. And we don't actually know whether that works. It probably works by increasing levels in the bloodstream massively. But some people think it goes by a specific pathway directly into the brain, and we haven't actually figured that out. There's people in both camps, right? But you give a lot of oxytocin intranasally, like 50 units or something like that, whereas in labor and birth you might give 3 units total. So in labor and birth, so you get these massive doses, you get these massive increases in the bloodstream at those very high levels. We'll come back to that. It probably crosses into the brain, and then it has effects in the brain. So all of those areas, they've kind of generally a little bit of evidence in most of those areas of some benefit for oxytocin. But as you say, it's not all good. So one of the studies they did was they actually gave women with postpartum depression oxytocin to snort, intranasal oxytocin. And those mothers actually expressed more aggression towards their children. So we can't quite explain that, but somehow it could increase aggressiveness. And I guess what it boils down to is, it's a complex, interrelated biological system in our brain, and it's not a drug. It's not just a drug, yeah. So when we're interacting with that system, we can't necessarily predict what the outcomes are going to be, and every pharmaceutical company is looking for some kind of oxytocin, we say analog, because the other thing about oxytocin, it has a very short half-life. It doesn't last very long in the bloodstream. We can't swallow it. It's not easy. Doesn't go it's broken down in the gut, so it doesn't go into the bloodstream easily. We can't take an oxytocin pill. That's why we have to snort it. We can give it into the body. But as I said, I'll explain this. So it doesn't easily cross the blood-brain barrier. So I'm going to go into what that means. So the blood-brain barrier is I think of it like a fence around our brain. So our brain is really important, right? What happens in our brain, we wanted to be able to control our neurochemistry, like the things inside. We don't want anything coming in and meddling with that, right? We don't want any old random hormone coming in. So we have this blood-brain barrier. It lets some things in, but not others. It lets some things out, but not others. So the blood-brain barrier, like all biological membranes, is actually lipid. It's made out of it's fat soluble. So things that go into the brain tend to be fat soluble. So like anesthetics, analgesics, painkillers, we want them to go into the brain, so they're fat soluble. But oxytocin is not fat soluble, yeah, and it's a very simple molecule. It's only 9 amino acids, so it doesn't actually cross the blood-brain barrier in significant amounts. So when they've done studies, about 1,000th of what's in the blood crosses into the brain. So if we want to get those high levels in the brain, we've got to give these massive doses into the nose or into the blood, however. So if we do give these massive doses, yes, it can cross into the brain. But if we give, if we give lower doses, like we were saying in labor, then levels aren't high enough to cross into the brain in significant amounts. Yeah, 1,000th of it is not very much. And anyway, as I mentioned, oxytocin is massively being produced in the brain in labor and birth. So even a little bit crossing over doesn't really matter. And I'll just explain this as well. I'll come back to the placenta because, before I started doing this research and looked into it in that paper, I had this worry that oxytocin given to the mother, synthetic oxytocin, is going to cross to the baby and cross to the baby's brain and cause all these problems for the baby. But the thing is, oxytocinase, I mentioned it, it's made by the placenta in the placenta. So any oxytocin that gets into the placenta in the maternal circulation actually gets broken down by oxytocinase. So it doesn't cross to the baby. Again, maybe 1,000th of it, but again, the mother's levels aren't that high at that high. And in that paper I just mentioned, the baby has even higher oxytocin levels than the mother. So the baby's oxytocin production is getting massively stimulated in labor. So it has all of those calming, connecting, pain relieving effects. And not only that, but oxytocin also has antioxidant, anti-inflammatory effects, protects the baby's brain. So all of these benefits for the baby from the baby's own release of oxytocin. Yeah. And I went back and actually looked at the animal studies where they'd actually found differences from giving the mother synthetic oxytocin in labor, or actually most commonly giving it to the baby straight after birth. And they gave massive doses, like up to hundreds to millions of times from what you could possibly give to a laboring woman. And you can't give a laboring woman that much, right? Because of what we mentioned, these increase in oxytocin receptors. I'll just give you a number. So they've actually measured oxytocin receptors, or the density of them, in actual real live women, and from non-pregnant through to late pregnancy, they're thousands of times higher. So the woman in late pregnancy, or the person in late pregnancy who has estrogen, is going to have this massive upregulation or increase in oxytocin receptors, which means that even a little bit of oxytocin is going to have a major effect on her uterus. So that first paper, Oxytocin Levels in Physiological Birth, the levels that women produce in early labor are actually quite small. If you're a midwife, you might think of, infusion rates, milliunits per minute. It's equivalent to about 4 to 6 milliunits per minute. That's how much we release in early labor, but it causes contractions because of that massive increase in uterine sensitivity from the massive increase in oxytocin receptors with the physiological onset of labor. Even late pregnancy, it's still not that high. It's still 3 times more at the onset of labor. And I'll just share an anecdote about that to illustrate it. So I actually breastfed through my second pregnancy. I was feeding my toddler, and every day she'd come in the morning and have a little suckle. That was fine. But the day I went into labor, she came and had a suckle, and I had to literally throw her off. I got this massive contraction. So the day before, nothing. Yeah. The day of labor, massive increase in my uterine oxytocin sensitivity from that increase in uterine oxytocin receptors. So the take home is we can't give laboring women very much oxytocin, synthetic oxytocin, because of her sensitivity. It's going to cause harm to her baby. So the doses that we give are quite moderate. As I said, total of 1 to maybe maximum 10 units through the whole course of labor, as opposed to what you can give to people outside of labor, which is dozens of, 50, 60 units, 80 units intranasally. So you just can't get high enough levels to cross the placenta or cross to the maternal brain. And anyway, the baby's making it, the mother's making it. So and also the other thing, we, in some of these studies of synthetic oxytocin, that actually measured women's oxytocin levels with synthetic oxytocin, and they were like 3 to 4 times higher than physiology. That's not 1,000 times higher. That's not going to cross the placenta. That's not going to cross to the baby. And even with synthetic, with synthetic oxytocin, the baby's levels weren't higher either. So some studies actually measured the baby's levels after the women had been given synthetic oxytocin in labor, and they weren't higher, which is what we'd expect from everything that I've said to you. So oxytocin is not going to cross to the mother's brain. It's not going to directly cause these effects. It's not going to cross to the baby. It's not going to cross to the baby's brain and cause these direct effects. It actually mathematically can't do that. So but I'm not saying that it can't cause indirect harm. So we can talk about that as well.
Yeah, that's fantastic. And thank you so much for clearing that up, because I think when we've been chatting, I was like, so on one side I was reading, it doesn't cross the brain barrier. So it can, but in doses that just wouldn't make any odds, really. It wouldn't cause any physiological changes for mom or for baby. So I guess we're both right. Yeah. So it can, but it's just not going to do anything. Yeah. Okay, good. Because what I was looking at was the levels of inflammation in the body. And then I had read something recently about, I think they were looking at studies in mice where they had given mice 2 weeks worth of drinking water out of plastic bottles. And what they found was enough plastics, nanoplastics and microplastics within the mice brains was equal to the size of a credit card. So I'm thinking, well, if plastics are getting through, we just need to give the plastic is a whole other conversation, but
well, plastics are, well, plastics are made from fossil fuels, and fossil fuels have that the rigs, they have a basically fat soluble. That's why they're so problematic. They cross membranes, they get into our fat, we store them in our fat. All of these they're estrogenic like. They have an estrogenic like effect. So, yeah, that's a different category. And as I say, we say lipophilic, lipophobic. So, like lipophilic, fat living things can cross membranes. Lipophobic generally don't. And again, it's there's also it's a little complex in the blood-brain barrier. Some things are actually prioritized. There's mechanisms that bring some things in. Some things have mechanisms for getting out, like oxytocin has this portal circulation through the pituitary that gets out. Other things don't. So, the body is an immensely complex and, I say, superbly designed. Yeah, superbly designed for all of these reproductive things that we're talking about.
It has been superbly designed, and then we started doing all this stuff with plastics, and back in our cave woman days, we didn't have to think about all of this inflammation in the body, and just how our environment is affecting our reproductive system. Like when we look at like fertility rates dropping, and like chronic illness increasing in the world. So tell me, I mentioned to you earlier, so a lot of people have, and especially within the birth world, that synthetic oxytocin, the thinking is very black and white around it. It's like synthetic oxytocin is bad, no good can come of it. But you have some ideas about how it actually could be beneficial, and will you talk to that a little bit and balance the the curve
Yeah.
a little bit?
So something I haven't mentioned is how oxytocin levels get so high in labor and birth. And just going back to some basic biology, which is a concept called homeostasis. So we're all sitting here, our body's in homeostasis. It's the process that keeps our biological systems even in the face of change, external, internal change. So we're sitting here, there was suddenly a loud noise, and we'd get a fright, we'd get our fight or flight system would get activated, our heart rate would go up, our blood pressure would go up, we're ready to flee. But then we realize it's okay, it's not a danger to us. Our body has this feedback system that detects those high levels, we don't need them, and brings them down. So that's a negative feedback system that keeps us in homeostasis, keeps us the same. But labor is not a homeostatic event, right? Things don't stay the same in labor. Things start, I say it's the snowball of labor. It starts small, becomes bigger and bigger, and in the end becomes virtually unstoppable. And the reason for this is because labor is actually a positive feedback system. And there's several positive feedbacks in labor, and you can look at my hormonal physiology report about that. But probably the most important is what people might know as the Ferguson reflex. So basically what happens is the sensations of labor, the baby moving down lower, the pressure on the lower vagina and cervix, sends feedback to the brain by a specific nerve pathway, and in labor. And when that message message of those sensations gets to the brain, it actually causes an increase in brain oxytocin. So brain oxytocin release from the brain increases, goes to the uterus, causes stronger contractions, more pressure, more signals to the brain, more oxytocin release. So it's a positive feedback loop. It's like a snowball getting bigger and bigger, and in the end becomes virtually unstoppable. Yeah. And the snowball actually depends on the sensations. So you can ask me later about what happens when we lose the sensations with epidurals. I won't cover that now, but it depends on the positive feedback loop, right? And it's quite interesting, what I think about this is my own opinion, is that it kind of explains why so many things can initiate labor or speed labor if we're close enough to the onset of labor. If we've got enough oxytocin receptors, we get onto this feedback loop, which is kind of like active labor, right? There's this kind of little messing around bit, in before active labor and then the onset of labor, where things really start going, and this positive feedback loop and the snowball gets bigger and bigger. But if anything, that increases the strength of contractions, like taking castor oil gives you more contractions, having sex gives you more contractions, could actually increase this positive feedback loop. And I recommend people go to my website, sarahbuckley.com, and look at my blog, the Epidural blog. There's actually a picture of this feedback loop, and it's going to be an upcoming paper too, actually. We've made a really nice one. So with this feedback loop, it's not just when Ferguson discovered it, and it was a very interesting experiment. When he discovered it, it was about oxytocin in the bloodstream, which which we can measure. But if you think about the feedback from the sensations going to the brain, it actually increases oxytocin release in the brain as well. So at the same time as the uterus is getting stronger, the contractions getting stronger, labor speeding up, we get this release in the brain. So all those calming, connecting, pain relieving, actually, I think I didn't mention oxytocin has pain relieving effects as well, very useful in labor and birth. So calming, connecting, pain relieving effects, switching on the parasympathetic nervous system, which actually in itself triggers labor and birth. It's almost like another pathway to the processes of labor and birth, and activating the reward and pleasure centers. Because once labor gets going, obviously the baby's going to be born soon. The mother wants those reward and pleasure centers activated. So all of those things are happening in the brain as well. So this positive feedback loop, so things that stimulate the positive feedback loop could increase brain oxytocin as well. And some of the things we know in women, for example, we mentioned the sensitivity of the skin. So we think probably the brain oxytocin release somehow triggers that sensitivity of the mother's skin. So she releases a lot of oxytocin in skin to skin contact with her baby, which, as I mentioned, doesn't happen if she doesn't have labor and birth. With a pre-labor cesarean, there's no sensitivity there. She doesn't release significant amounts of oxytocin. Also, the other thing that happens, and this has been measured in women as well, is we get these changes in personality. And you can imagine that we need some things to help us look after our babies, right? So mothers report themselves as more relaxed, less tense, less psychological, less anxiety, less psychic anxiety, less muscular tension. All of these things happen through those processes of labor and birth that don't happen for women who don't have those peaks of oxytocin. Yeah, so it's part of what we might call maternal adaptations that happen in all mammals to help us to look after our babies and make it as rewarding as possible, right? It's meant to be pleasurable to kind of offset the immense effort involved, right? To motivate us, to reward and motivate us. So these things are happening through that process of release of oxytocin in the brain. So we're going to go shift now to synthetic oxytocin. So and again, I recommend that you go to my website, all the science, and then find this paper on synthetic oxytocin and read it. It's got a lot of good information in, but we've also got a really nice figure there of what is actually happening in the mother's body, the baby, and the mother's uterus during the processes of labor. So what happens is these oxytocin and other mechanisms, actually prostaglandins, other micro biochemical things are happening to make the uterus contract. And the uterus is a muscle, right? It's a uterine muscle. And what happens when you work a muscle hard? Yeah, like you go for a run, you go for a long walk, you go to the gym, you get a sore muscle, right? You get a sore muscle because you're building up lactic acid in the muscle. And you get lactic acid because you're overworking it to some extent. Your muscle's not used to it. You get lactic acid build up, it gets sore, you rest it for a while, the blood flow comes through, clears out the lactic acid, and the pain goes away. And that is actually happening with every contraction. Again, look at the model. So, the uterine contraction builds up. As the uterus is squeezed, not only is it squeezing, causing a contraction, but it's also squeezing all the blood vessels. It's for the mother. So it's actually reducing blood supply at the same time. So it's reducing blood supply, but also the muscles are working harder. So you get this buildup of lactic acid. And we think that the lactic acid might even contribute to the cessation of the contraction. It might be what causes contractions to start and stop. The lactic acid is kind of a signal of stress. You get this kind of biochemical stress in the muscle. It even shifts within that single contraction from the parasympathetic oxytocin into the sympathetic. So you get the sympathetic come in, the lactic acid build up, and then the contraction finishes. And it kind of explains why, if you've observed this in hospital, I said oxytocin is released in pulses, right? But when we give synthetic oxytocin in labor, we give a constant dose, but the woman still gets cyclical contractions. Why does that happen, right? It's because of this mechanism happening inside the uterus of the stresses building up with the contraction, and then the contraction eases, the blood flow comes back, the lactic acid clears out, the pain or the stress in the muscles goes away, the sympathetic goes down, then there's space, oxytocin comes in, and we get another contraction. It was interesting in this paper that one of the papers we looked at, they actually measured oxytocin during a single cycle of contractions. And what was interesting was oxytocin levels actually peaked between the contractions, not as the contraction was happening. And we think that the contraction itself probably reduces oxytocin through that kind of micro stress of the contraction, if that makes sense to you. So kind of contraction and relaxation is happening on lots of levels as the contraction goes through. So we think that part of the problem with synthetic oxytocin is it's basically overworking the muscle. It's kind of overriding that endogenous, that natural system that makes the contraction stop, and you get a rest in between. So with synthetic oxytocin, the contractions are stronger, so more hypoxia, more lack of oxygen, more lactic acid buildup. But the other thing that happens, and this is really important, is they get closer together. So there's not that time in the middle to recover, which is really important for the uterus and really important for the baby, as we'll talk about. So more stress, less recovery with synthetic oxytocin. So what we think is that, especially with high levels of synthetic oxytocin, it basically increases stress for the laboring woman. And there may be effects downstream that happen because instead of having this kind of parasympathetic oxytocin kind of experience in her body of labor and birth, she's getting more of a stress experience. So particularly with higher doses. So that's one of the mechanisms. But just going back to what you said about possible benefits of it. So the other thing that's happening, if we go back to our positive feedback cycle, I have to go back to my blog. So if you remember that, that's the strength of the contractions that causes the sensations, that causes the increase in the brain, right? So anything that makes a contraction stronger could fuel that positive feedback loop and actually end up increasing oxytocin in the brain, right? So slow doses of synthetic oxytocin, we hypothesize, we can't measure this, no one's measured the brains in laboring women, fair enough. So stronger contractions could even get our positive feedback loop going more strongly. So as long as it's not so strong that it gets kind of counteracted by the stress system, then low doses of synthetic oxytocin could increase brain oxytocin release. And there's actually a couple of studies, or one study that showed that, where they looked at the personality changes. And these were women who had reasonably low doses of synthetic oxytocin. They actually had more personality changes when they had synthetic oxytocin compared to not. So more of those benefits from the brain. So I'm not saying everybody should have it, but I'm saying it's not the devil that we thought it was. And one more thing, which is going back to that study, and this was kind of a beneficial coincidence that happened in the study. So what happened is, this is one of my colleague Kirsten Ivnas-Moberg's PhD students. So she got a pre-labor cesarean population, and straight after the birth, the babies were randomized to skin with the mother or skin to skin with the father. Yeah. And they measured the mother and the father's oxytocin levels during that skin to skin contact. And neither of them actually released any significant amount of oxytocin. It was maybe 10% up, but it wasn't significant. But it was the same whether they were in skin to skin contact with the baby or not. And particularly the women who'd been through this pre-labor cesarean without everything we've just talked about didn't release oxytocin in skin to skin contact with their baby, versus, remember the study that I mentioned, where women can have up to 10 times more oxytocin in that first postpartum hour. So no oxytocin release. But what happened in this study was all the women got the kind of standard synthetic oxytocin, 5 international units with the cesarean, right? It's kind of standard practice. But some of them, for medical reasons, maybe their uterus didn't quite contract properly, they got an infusion. I think it was like 30 units, I think, maybe 50 units. Anyway, they got an infusion. And those women that had the skin to skin plus the infusion did release significant amounts of oxytocin, of endogenous oxytocin. So something about that, in that way, the synthetic oxytocin in that circumstance is almost like filled in that hormonal gap of labor and birth. Yeah, and they're not 10 times as much. We're not talking about physiological levels, but they release significant amounts. So that's really interesting. And it's not enough. It's one study. It's not enough to say every woman should have synthetic oxytocin after a cesarean, but it's an interesting finding. Yeah, that kind of fits in with everything that we've said. And also it's a good illustration that synthetic oxytocin is not necessarily the devil. Yeah, too high doses causing stress, not a good idea. But the other thing we haven't talked about, and I can come to this in a minute, is the other problem with synthetic oxytocin, it causes contractions that are stronger and closer together, and it can override our own endogenous pain systems. Yeah, we've got a whole lot of systems, oxytocin, endorphins, that help us to deal with the stress and pain of labor. And generally, labor gets stronger and stronger. And if we think about the positive feedback loop, the stronger the contractions, the more oxytocin release in our brain to counteract them, right? But synthetic oxytocin overrides all of that. So most women who have synthetic oxytocin need some form of pain relief, right? And often it's an epidural. And we think that the combination of synthetic oxytocin and epidurals is probably, or the epidural itself actually, is more consequential for the oxytocin system than the synthetic oxytocin. And most of the studies that we've looked at, most of the studies of synthetic oxytocin outcome haven't actually looked at the co-intervention of epidurals, which is very, very common. And, a lot of women, anyway, we can talk about epidurals in a minute, but I'll just pause there for a minute.
Yeah, that's just fantastic, Sarah. And that is so interesting that when we give women an infusion, that it can help with that skin to skin after a pre-labor cesarean. And yeah, there's so much here. I'm going to have to sit and listen to this podcast another 10 times because there's so much information there. Yeah, and so yes, tell me what are epidurals doing to the brain and to the oxytocin mechanism?
Yeah, so just a bit of background. So, as I said, we've done this systematic review of oxytocin levels in physiological birth, which is a great foundation, oxytocin levels in breastfeeding, and now we're doing interventions. So, we've done synthetic oxytocin, and right now I've almost finished a paper on oxytocin levels with Cesarean, which is some of that data I just gave you. And I'm also getting to the end of a parallel paper on oxytocin levels with epidurals and opioids. So I can talk about what the studies have found. So these are studies that have actually measured oxytocin levels with epidurals in labor. So it's very important, the in labor thing, because in labor, this positive feedback loop is going and oxytocin levels go up. When we're not in labor, that doesn't happen. So if you have an epidural for a cesarean, for a pre-labor cesarean, it's not really going to change your oxytocin levels because you don't have that increase to start with. So going back to our positive feedback loop, we have the contractions causing the sensations, leading to the brain oxytocin release, leading to oxytocin release to the uterus, and more contractions, our positive feedback loop, right? So the problem with epidurals, or the good thing and the bad thing, is they're so effective at reducing pain, and they're using local anesthetics injected into the epidural space that do, these are lipophilic drugs that cross into the nerves, that transit through that epidural space beside the spinal cord, basically causing numbing of those nerves, or causing blocking of the motor and the sensory aspect of those nerves. So you get blocking of the sensory aspect, you get that numbness, which is what you want to reduce pain. You also get blocking of the motor aspect to some extent. So you lose some movement, some capacities. Yeah. So with all of that, you lose the sensations, which is the feedback that fuels this positive feedback loop. So what we found in these studies is that when women have an epidural, their oxytocin levels slow down within an hour, they level off. And generally between women who've had an epidural and not had an epidural, there's quite a significant, maybe 50% gap in oxytocin at birth and after the birth. So the oxytocin levels go down. And if we think about our positive feedback loop, it's not just what we're measuring in the bloodstream, but all of those things are going to happen in the brain as well. So we're going to have less oxytocin and all of those effects we just discussed in the brain. So, studies have found, for example, that those personality changes don't happen in women who've had an epidural. Some of the studies not published yet that have been done with the skin-to-skin contact found that the women didn't release as much oxytocin in skin-to-skin contact with their babies with an epidural, which is probably a central effect from whatever it is, whatever central mechanism it is that causes the mother's skin to become more sensitive through those peaks of labor and birth. So, a big oxytocin gap with epidurals is basically the take-home message there. And then what often happens is oxytocin levels go down, labor slows, and then you give synthetic oxytocin to fill in that hormonal gap. But because of the lack of sensations, it doesn't fill the gap the same way because, you're not getting those sensations to cause the increase in oxytocin. So it doesn't actually fuel the positive feedback loop. So, yeah, unfortunately, it's difficult to feel that positive feedback loop with epidurals, because the synthetic oxytocin doesn't have that same effect, because you don't get the sensations, and then you have that less sensitivity after the birth as well. So in that early sensitive period with an epidural, basically it's less sensitive, and we can talk about hormonal gaps in a minute, but I'll stop there.
No, please continue. It's yeah. I
Yeah.
have no more
Okay.
questions. This is yeah. I'm just soaking it all up, and my oxytocin levels are flying. So yeah.
Okay, so let's talk about hormonal gaps, because it all sounds a bit like doom and gloom if you have an intervention. And look, these interventions can be useful; they can be life-saving for mothers and babies, right? So that's important to know. But actually, one more thing to say about epidurals before I go on to hormonal gaps, which is that sometimes labour and birth are so stressful for the labouring woman, and her cortisol levels are up, and actually her sympathetic nervous system is overactivated, and she's stressful and she's tense, and that can inhibit labor itself. So sometimes, and this is not the majority, but in the minority of cases, sometimes a woman in that situation gets an epidural, her cortisol levels go down, her stress levels definitely go down, and sometimes she can have a rest and labor can actually resume. So there are some cases where the epidural is therapeutic. And if you're a woman out there or a birth worker out there, I'm sure you've seen this happen. Yeah, so that can be initially helpful. But then in the end, the oxytocin will go down and the contractions will subside to some extent. You'll get synthetic oxytocin. And also the other, major effect of epidurals is you don't get that peak of oxytocin that helps you to push your baby out, that positive feedback loop that's going so strongly in the pushing stage when the sensations are very strong, you might have noticed, and you're getting lots and lots of oxytocin, that 3 to 4 times higher to help you push your baby out. In the second stage, the pushing stage, you're not getting that. So that pushing stage is more difficult, longer, more likely to need help with that with an epidural as well because of that. So what can we do about these hormonal gaps when these interventions are needed? Pre-labor cesarean, even an in-labor cesarean, there's hormonal gaps with that as well, epidurals. So Mother Nature does give us some backup systems, and basically the backup system is skin to skin and breastfeeding. Yeah. So it's true that you're not going to be as sensitive to skin contact with your baby initially, but you still want to do it. There's lots of studies, and I've reviewed them in that paper, that found skin to skin contact is very beneficial after a cesarean. More maternal satisfaction, the babies are warmer, there's less hypoglycemia, the babies are less stressed. All of those things will happen with skin to skin contact after a cesarean. So much better than no skin to skin contact. So definitely in. And what's interesting about skin to skin contact, so we talked about birth and breastfeeding, this pulsatile oxytocin release. Skin to skin contact, it's not a pulsatile release. It's actually a more constant release, yeah? So it's not quite the same effect, but it will help to fill in those hormonal gaps. And as I said, there's no limit to skin contact, right? If you think about in evolutionary terms, there's nowhere for the baby to be except on the mother's body or someone else's body, right? So skin to skin contact doesn't, people say, how long should you do it for? Well, until you can't carry the baby anymore, basically. In evolutionary terms, yeah. So skin to skin contact, always beneficial, increases oxytocin, soothing for the mother, soothing for the baby. I mean, you can listen to Nils Bergman's beautiful work about zero separation and how the babies become actually stabilized. And there was actually one of the cesarean papers saw that the baby's heart rate, all of the baby's systems become stable in skin to skin contact with the mother. And this is for premature babies. A lot of the research has been done, but it's true for term babies as well. That's where the baby expects to be. Yeah, the baby expects to be skin to skin on the mother's body. So good for the mother, good for the baby, skin to skin contact, no limit to it. Yeah. And the other thing is breastfeeding. So breastfeeding as early as possible, as frequently as possible. Again, there's no limit to how much you could breastfeed. And it seems like exclusive breastfeeding particularly is good for filling in hormonal gaps. So I talked about the women with epidurals who didn't get those personality changes. So those women who exclusively bred for 4 to 6 months, breastfed for 4 to 6 months, did get those personality changes. So So that's basically Mother Nature's medicine, skin to skin and breastfeeding. There's no limit to it. But again, just going back to the hormonal gap, it's not just a hormonal gap for the mama, it's a hormonal gap for the baby as well. There's a whole lot of processes, labor processes happening for the baby that prepare the baby for life outside the womb. Again, you can read it in my report, catecholamine surge, the baby gets activated on every level, the baby gets woken up. And I always think for the baby, a pre-labor cesarean is like someone coming into your bedroom at night and you're all snuggled up and you're cozy in your bed and it's dark and you're asleep and you suddenly get woken up with a bright light and you get dragged out into the cold and you're just not ready to wake up, right? So that's the experience for the pre-labor cesarean baby. So they're not ready to breastfeed. They're not ready to breast crawl, So we've really got to give them that time. You have a lot of patience. You've missed that. I hope what's obvious is a window of opportunity, that early sensitive period where everything's lined up. The receptors are lined up, the oxytocin's lined up, the hormones are lined up, the baby's ready, for this magical moment. I say physiological birth, that hour afterwards, it's like the best first date ever. The mother's full of oxytocin, the baby's full of oxytocin. They're fired and wired to fall in love with each other and be rewarded and motivated and survive the species, right? So if you miss that early sensitive period, you have to be more patient. It's going to take longer. You're going to have to keep doing things. And again, an anecdote, which is a birth story I read in a birth magazine of a woman who'd had 2 natural births, home births, I think, knew what it felt like, had to have a pre-labor cesarean for her 3rd baby. And she said, when I got my baby after the cesarean, which can take a while in itself, right? We can talk about that as well. But my baby felt different. And it's true, the baby was in a different hormonal state. She was in a different hormonal state. She said, my instinct was to be skin to skin with my baby. And after 3 days of skin to skin, my baby felt the same. So, an hour of labor, everything's done. You miss that window of opportunity, 3 days of skin to skin. Yeah, I can't say that's research evidence, but it makes sense. Yeah, filling in those hormonal gaps. So being more patient, taking the time, exclusive breastfeeding, skin to skin contact.
Lovely. And it's similar to, I guess, some of the studies on the microbiome where if moms got antibiotics in labor, that how the baby's microbiome was affected, but skin to skin breastfeeding, exclusive breastfeeding, I think for the first 3 months, then they seemed to, it improved the baby's microbiome, and it was, I think 3 months later, it was similar to if they'd been had a vaginal birth. So there is that the backup system, breastfeeding and skin to skin is, and I think it's Carolyn Hastie in Brilliant Midwife. I think she's an Australian midwife. Had written a lovely paper years ago about after baby has arrived, and because we talk about undisturbed birth, keeping the lights dim, but she talks about continuing that into that postpartum period, like the golden hours, should we say, keeping the lights dimmed and keeping mom warming, because we want, again, keep that hormonal balance as labor-like as we can, so that mom and baby have the opportunity to get to know each other in dim lighting. But here in the US, it's very, very different. It's lights on and everyone walking around and strangers, and it's only until I guess parents get to the postnatal ward or postpartum ward that they can really kind of settle in with their little one.
Yeah, and one reflection of that is that, we call it the 3rd stage of labor till the placenta comes out, and it is labor, and it's actually even more exquisitely sensitive time than the actual labor and birth. We think nothing is happening because it's not as dramatic as labor, but these incredible changes are happening inside the baby. The circulation's getting rerouted. They've never breathed before. All of those changes have to happen. Ducts close, ducts open, the heart wall seals, and for the mother, like, she's spent 9 months getting pregnant, and in a minute she's not pregnant anymore. So enormous changes happening for her. So the sensitivity of the time, and also, the oxytocin is vulnerable, to feeling safe. So she has to feel safe in that time to release her oxytocin to contract her uterus and save her life, right? And if we do all these disturbing things in that hour after birth, we might predict that we could cause postpartum hemorrhage, and postpartum hemorrhages rates are rising around the world, and we can't really explain why, But counteract that, the other good thing, and we talked a little bit about this, is the recognition of the importance of skin to skin. So the World Health Organization has a program called the Baby Friendly Hospital Initiative. So if you're listening to this and you have the choice, I would really recommend that you choose a baby that's BFHI certified, because those hospitals have to tick all these boxes, and one of them is an hour of skin to skin between mother and baby afterwards, whether you have a cesarean or not. So that's really important. And as I said, with the cesarean, you really want the baby on your body as soon as possible. And some of the new kind of gentle cesarean, family friendly, lactation friendly, there was another name. Anyway, look for, if you do have to have a cesarean, look for the most skin to skin friendly. And some of these ones, the baby can actually go straight on the mother's body, no separation at all, delayed cord clamping. These things are possible. I mean, they take more forethought, more resources. You might have to negotiate for what you want, but I've actually got a blog about that, how to have the best cesarean. So if you do need a cesarean, there's ways you can fill in that hormonal gap. And at the very least, if you can't have skin to skin, you can see some pictures of this, but there's some beautiful, they call it cheek to cheek. So the baby going cheek to cheek with a mother can be very soothing and healing, if nothing else.
Yeah, that I think it's the maternal assisted cesarean. I think is the latest, where mom gets to scrub in literally for her own cesarean and reaches down and takes her baby up herself.
Yeah, beautiful. Thank you. I have to put that
And
on my
actually,
list.
it's Dr. Natalie Elphinstone in Canberra, I think she is. She's doing all these
Melbourne.
great things in Australia.
Yeah.
Yeah,
Yeah. She's in Melbourne. Yeah, she's a good woman. So good.
she's
Yeah. Yeah.
fantastic.
But some of those are from America too. Some of those more gentle cesarean techniques too. The natural cesarean is another name. But yeah, look for that kind of, if you do need a cesarean, look for that kind of capacity in your hospital system. Yeah.
Yeah. Sarah, thank you so much for a really, really fascinating. I can't wait to listen back to this again. And because I was taking notes, and why am I taking notes? I can listen back to it again. Really phenomenal. Thank you so much for taking the time to spend with me today, and for reaching out about the blood brain barrier, and getting that cleared up for everybody. I think that was really helpful, because it is. I think it is out there in the ether, and now kind of I feel like I'm more informed now, so I'll go and kind of and write a little on that as well, and share it, so that I guess we can all share the knowledge.
Thank you. It's a bit hot off the press too. So yeah, thanks for spreading the love. Yeah.
Sarah, where can people find you? And just remind again, your books, CDs.
Yeah, so my website's sarahbuckley.com. My book's Gentle Birth, Gentle Mothering. It's on all the Amazons as well as here in Australia. I've got lots of blogs that are really informative over there, and sign up for my newsletter. My next blog coming out is about some of the things we've talked about, like does synthetic oxytocin harm the baby is the title. So if you sign up to my newsletter, you'll get that notified when that blog is out. Also, as I said, I'm working hard on my cesarean paper with all my colleagues, and epidurals as well. So again, that will be notified. You can also follow me on Facebook. I do quite a lot of Facebook, Dr. Sarah Buckley, Instagram at Sarah Buckley, Sarah J. Buckley. Sorry, I can't remember. Look, research for me. I think I'm at Sarah J. Buckley. Yeah.
I will. I'll be sure to include everything in the show notes, so people can find you easy enough. So, but I appreciate it. Enjoy the rest of your Tuesday
Thanks so
in
much, Tracy.
Australia.
Thanks for taking the time, and
Thank
all
you
the best to all
again.
the listeners. Okay, bye.
Thank you. Thanks, Sarah.
Thank you so much for tuning in to today's episode. Remember, empowerment begins with knowledge. If you enjoyed our time together and want more content like this, don't forget to like, subscribe, and share with your friends. So stay inspired, stay informed, and until next time, take care of yourself.